Well, here's a very typical exam 1 question for you guys. We've got to solve this equation. Y equals 5 cos 2 times x minus pi on 3 equals 0, where x has a domain from minus pi to plus pi inclusive. Now this kind of thing sends absolute shivers down many students' spines, and I'm going to show you just how easy this is to do. So just stick with me and hopefully you'll get something out of this. It's a very typical level for exam 1, okay? Now what I like to start off with is what I call the working domain. Many students are mystified by this when I start sprouting off about the working domain, but it just enables me to harvest all of the solutions that I'm going to need before I get to the final end and then have to discard a whole lot of them because they're out of range. If x is allowed to go from minus pi to plus pi inclusive, guys, what I'm going to work up to is what this thing in here would then go to the equivalent of, okay? So just watch. Therefore x minus pi on 3, now I'm taking pi on 3 from each of these two terms, each of these limits, okay? That's what I get now, and now I'm going to double this. Therefore 2 times x minus pi on 3 would go from minus 8 pi on 3 to 4 pi on 3 inclusive, and I call that my working domain. That is the domain over which I'm going to harvest all my solutions, okay? Now, we've got to get to the bottom of this. We're looking at when 5 cos of something equals 0, or in other words, just when cos of something equals 0. Well, we know that when cos is 0, we're talking about pi on 2 is the first occasion to the right of the y-axis for the graph of cos, where the value of y equals 0. And then, if you think about it, if you just draw that graph in your mind and visualize what it's doing, oscillating around, you'll notice that it hits the 0 line every pi after that. And indeed, you could make this k beastie here any integer at all, positive, 0 or negative, in order to capture all of the solutions for, say, a general solution situation. But what we will do is we will capture all the solutions within our working domain, okay? Within the working domain, we know that 2 times x minus pi on 3 would be, now, what I'm doing here, guys, is I'm going backwards first, and then I'm going to go forwards, because I've got to capture everything from the 0 point backwards as far as minus 8 pi on 3, and then subsequent to that, I've got to go forwards as far as 4 pi on 3. But this bit here is just to take into account all the backwards solutions. So I've gone minus pi on 2, take another pi off, minus 3 pi on 2, another pi off, going backwards is minus 5 pi on 2, and then minus 7 pi on 2. Now, goodness, I've got to work out what all this means. Unfortunately for us, this has got a 3 on the denominator, and all these have got a 2. So it looks like I probably need to convert them both to, say, 6, the lowest common denominator of 3 and 2. But before I do that, I'll just go forwards and identify that 2x minus pi on 3 could also be, in the forwards direction, pi on 2, or 3 pi on 2, or 5 pi on 2, and so on and so on. Now let's just get our bearings here and work out what on earth we're doing here, guys. So, as I foreshadowed, I'm just putting the working domain with a denominator of 6 now, so we can talk apples with apples in accordance with this and with what we're getting over here. So, minus 16 pi over 6 to 8 pi on 6. Okay, that's our working domain now. Our solutions were, what I'm doing here is I'm multiplying each of these, top and bottom, by 3, so I can make the denominator 6. So see that, does that check out? Yes, yes, and yes. It's the top and the bottom by 3, okay? So I haven't changed the fractions around, I'm just making them so that they're over 6. Now, this one here, you can see, is minus 21 pi over 6, which is too far. But this one is still in, that one's out of range, so that one I'm discarding, okay? And I've honed in exactly, precisely on which solutions I'm going to need. Then, similarly, in the forwards direction, I know that 2 times x minus pi on 3 could be, I'm multiplying these top and bottom by 3. So I've got 3 pi on 6, 9 pi on 6. Now 9 pi on 6, let me see. It's too far, guys, so I'm going to chuck that one out. That's out of range. Discard that one. Alright, so therefore I've got all my ducks in a row now. So I'm going to set them all out logically from the very least to the very highest as a little equation. So 2 times x minus pi on 3 could be, this is the least, that's the next one, that's the next one, and then going in the forwards direction, that one. And that's all, isn't it? Yes, because that one's out of range. So now, for my final knockout punch, I'm going to solve this thing for x. Okay, so I better divide both sides by 2 first of all, and I get that, dividing everything by 2, and then I'm going to add pi on 3, which would be how many twelfths? It would be 4 twelfths of pi, wouldn't it? Yeah, 4 pi over 12, so add 4 to all of those numbers on the numerator on the right hand side, and we get x is minus 11 pi on 12, minus 5 pi on 12, pi on 12, or 7 pi on 12, and there's no simplification for any of those fractions, is there? Have we got it right? Yes, everything's good. We put a box around it and it is sweet. Yes, everything's beautiful, and we can get out of there now and we can be happy that we've got the thing solved correctly. Alright, see you soon.